I'm here to tell you a little more about the atom. It's hard even to comprehend just how small an atom is. If an apple were enlarged to the size of the Earth, all the atoms inside would be the size of cherries. Now that's small. You already know the atom contains negatively charged electrons, moving around a very tiny nucleus, which contains positively charged protons and neutrons with no charge. In this model, like most models of the atom, the relative sizes of the subatomic particles are not realistically portrayed. If an electron had the mass of a penny, protons and neutrons would have the mass of a large bowling ball. The actual masses are really quite small. However, if we compare the relative masses, it is easier to see the extraordinary difference in mass. Even though protons and neutrons make up the bulk of the mass of an atom, the nucleus is extremely small with respect to the size of the whole atom. Recall that when we look closely at an atom, we find that the atom is mostly empty space. If an atom were the size of this fine football stadium, the nucleus would be the size of a flea in the center of the football field. Because the mass of the atom is so small, scientists use a more convenient measure of its mass. This is called the atomic mass unit, or AMU, and it is based on the masses of the atoms relative to the carbon-12 isotope, which has a mass of 12 AMU. The atomic mass of an element is a weighted average mass of the atoms in a naturally occurring sample of the element considering the relative abundance of each isotope in nature. For example, if you look at the relative abundance of the most common isotopes of carbon in a natural sample, you can see that the atomic mass of carbon, 12.0107 AMU, reflects the 98.9% abundance of the carbon-12 isotope. The last distinguishing factor between atoms we will look at is the number of electrons an atom contains. A neutral atom has the same number of positively charged protons and negatively charged electrons, but atoms can gain and lose electrons. When this happens, they become ions. A cation is an atom that has lost electrons, and therefore has more protons than electrons, giving it a positive charge. And an anion is an atom that has gained electrons, which results in a negative charge from having more electrons than protons. To summarize what you have learned, atoms with different numbers of neutrons are called isotopes. The atomic weight or mass of an atom is the weighted average of all the naturally occurring isotopes of the element. An ion is an atom that has gained or lost electrons and has a corresponding positive or negative charge.